There are only few phenomena in nature which can be as disastrous and which can be as awful of sorts like a tsunami. Tsunami is a phenomenon in itself, and anyone who can go to imagine how big or how thunderous a tsunami can go on to be, that is seen to be believed. You will imagine that that is the basic reason that there are some films that have been made. They have showed the awe-inspiring tsunamis. A look at that is going to be a real one. This is a real one. This is the one that took place in Japan, and that is a dike that is protecting it. And this dike that is 20 feet wall has not been able to protect it. And you just go on to see 20 feet wall has not been able to protect it, and the water goes into spilling out of it. And imagine this scene. Just imagine that part. Now, what you need to know about in tsunami is that is what is a tsunami? That is what is the nature of the tsunami in this case? That's going to be one. What is the nature of the tsunami? How is it that the tsunami is going to look like, and how is it that they're going to behave? All in all, the second is how is it that the tsunamis are going to be caused? So one of them is of course going to be an earthquake. That is one part. Volcanic activity, landslide, then glacial tsunami, that is part of it, meteoritic impact, nuclear explosion, and ultimately, how is it that the tsunami is going to affect a lot of things. And when we're going to be talking about the effect, then we are going to be picking up a good number of aspects. Now, take a look at how is it, what is the nature of the tsunamis? That is tsunamis are not like, they are waves, but they are not like that of wind waves. This is how the wind waves going to behave. That is, they go on to stir the waters on the upper portion, and that the water starts oscillating in this place. After having got itself stirred, only the upper portion goes on to oscillate. It is this oscillation. That is, the particles in the water start oscillating in such a manner. This is how it takes place. That is one, and while the lower portion goes on to remain like that. But then once the tsunami goes on to be taking place, then what they're going to do is that they are going to be approaching the coast in this case. And when they go on to be approaching it, then in this process of approach, you will go on to find that is the waves will go on to become shortened, and that goes on to become the nature of the tsunami. Any type of a snapping that goes on to take place here, and that has taken place here, the whole of the water oscillates. This is the difference from wind-driven waves, because in wind-driven waves only the upper portion of the water goes on to oscillate, while when there is a tsunami, not only the upper portion, the entire of the water body starts oscillating in this manner. And in this process of oscillation, they're going to radiate themselves out from every direction. For example, one of those tsunamis, and the last tsunami that affected India, this was the place from where they got it themselves generated, and from here the oscillation took place in almost every possible direction. And before any tsunami that was to take place, the whole of this coastal region used to get itself, the water used to be getting itself withdrawn out of it. See, that is like when you have thrown something out into the water, it goes on to start generating its own waves. And first is that the water, see, this is the way that it is going to be taking place. And once it has taken place, any place where the tsunami is going to be approaching, the water withdraws. And once the water withdraws, then there is going to be a wave of sorts. So this is the way that the tsunamis actually go on to get themselves generated, and they start radiating. They start radiating in the same manner as you have thrown a stone into the water, and the waves start moving in every possible direction. And ultimately, a tsunami that has taken place from here, it will going to fill up the whole of the Pacific Ocean. That is going to be the nature of the tsunami in this case. One of the causes, having known how is it that the tsunamis are, one of the causes of tsunami is of course going to be the snapping. That is plates as they go on to break, that is the snapping that goes on to take place. When this snapping goes on to take place, the entire of the water oscillates. And as this water oscillates, you will go on to find that is the oscillation of this water will go on to cause a good amount of a movement. This is not only the upper portion that will go on to move. It is going to be all the lower portion that will start moving. In this case, for example, the movement will go on to take place all along this, all along the lower portion of it as well. As you're going to find it, that all of these segments start oscillating all the way from top to bottom. Not only that, the upper portion will go on to do it. And these tsunamis in the form of a wave, they're going to start approaching it, and these waves start getting themselves bigger and bigger as they go on to approach. This is going to be another sign of how is it that the particles go on to oscillate. As you can go to see in this animation, there is not only the upper portion like in the wind-driven waves, it is going to be all the lower portion that starts oscillating. So the whole of the water body comes in motion in a tsunami in comparison to any wind-driven wave of sorts. We have talked about this diagram where how is it once the tsunami is going to be generated. Of course, its waves go on to start covering the whole of this ocean basin. For example, this is a place where a tsunami has been generated in the Pacific Ocean, and these waves will start taking shape and start covering the whole of the Pacific region. That is the way the tsunami go on to be moving ahead as well. Now, when these tsunamis go on to approach the coast, as you can go on to find it, that is, see these waves. See these waves? That is the wavelength in this case. This is going to be the wavelength. The wavelength starts decreasing. The wavelength has started decreasing. The wave height and wave steepness has started increasing. In this case, the wave steepness has increased. And the ultimate net result is that the waves are going to be big enough that when they're going to strike the coast, they're going to strike with their full ferocity. That means actually tsunamis will go on to look like they are looking like innocuous bodies, very innocuous bodies in water. They will not going to look like that is a tsunami has actually taken place when you are going to be out into the open ocean. But the moment, this is largely because the waves are small. As you can go to see it, supposing there is going to be a boat in this place. This is the place where you're going to be having a boat in this place. And if there is going to be a boat in this place, that will not going to feel like that there is tsunami that has taken place. But the moment this boat is going to be in the coastal region, somewhere in this place, you can go on to find that the tsunamis actually go on to strike with all the type of ferocity, and the wave height goes on to increase. There's going to be another way in which you can go on to take a look at it. That is, this is a picture that again goes on to show that the wave steepness goes on to increase. And not only is it that the wave steepness has increased, that is, the wave steepness has increased to such an extent that the waves had gone to become very, very high, and they have struck the whole of the region with full force of sorts.